So today's topic is about Docker networking in OpenStack. What is there today? What was the history and what's expected next, and what is the work which is going on in the community in different areas inside OpenStack, and some of the work which is going even outside. The motivation behind this presentation is to actually address some of the comments and questions that our customers had when they came to us at PlumGrid, that they say Docker is something which is gaining a lot of momentum. It already has, especially container technology, and there are a lot of things going on over there. But in the networking space, there's a whole bunch of confusion around, and this is where I come in the picture and answer any of the questions that you may have around this area. So with that, a little bit about myself. I've been the member of OpenStack community for a few years now. I'm also a developer in the Neutron, Magnum as well, designate. I'm also the maintainer and the author of Networking PlumGrid, which is the PlumGrid plugin. If any of you would like to get in touch with me, this is where my contact information is. So today we will talk about what Docker technology is and why is it being rapidly adopted today. What's the motivation behind all the momentum that it has gained in past couple of years? What are some of its use cases which are used in the industry right now? And what is Nova Docker? How Docker is used as part of OpenStack? There are a couple of implementations, so we'll talk about what is there today and what is being implemented and what will be in the future as well. Then we'll come into the aspects of Docker networking. We'll talk about how the progress has been in past couple of years since Docker has been well known. What is done right now, what is under development, and what do we expect in the future? Things will change. Then we'll talk about some of the use cases. As one of the use cases where you want to have your virtual machines and containers to have common or homogeneous networking layer. And this will demonstrate through Neutron with the PlumGrid ONS plugin through a demo. And then in the end, we'll share some of the key takeaways from this presentation. So Docker to me is very hot today. We all know that. So to me, it's like a common packaging format, which allows you to deliver applications or run processes in isolation, in a sense that you can scale in any way you want. There is no surprise behind the success of this technology, and in last 1 year, 2014 has been great for Docker, and we saw some amazing growth in Docker community and also adoption in the industry, where we see stats like 100+ million Docker engine downloads, 45,000+ applications on Docker Hub, hundreds of community members, amazing presence on DockerCon. Also, if you go to GitHub, a lot of forks, a lot of stars. So all in all, in terms of stats, it's been doing very great. So we say Docker is being rapidly adopted, but what exactly is the reason behind its adoption, or container technology in general? Well, the reason is that Docker containers they boot extremely fast, and they are very lightweight in terms of their footprint, and that's why people are using them. And companies like HP and Oracle have been using them for a long time, but now it's coming to people like us, people who want to adopt it to a scale where it can go to all the developers and all the people who want to deploy applications in the world, and kind of be able to improve performance of running applications as compared to how we could do in virtual machines. So that's why, with such a light footprint of Docker or container technology, you could run like thousands of containers on a single host, which you could not do with virtual machines. That makes sense. That's the reason behind the explosion. But then we have to see what are the use cases that Docker offers, and then we talk about how those use cases tie to networking. So all the use cases that we have over here, that I've listed down over here, they are very ubiquitous use cases. They're seen everywhere. They would exist even for virtual machines, even for bare metal, and now the containers are there. We see the same use cases being adopted onto container technology. However, there is one thing which is common across all of them, and that thing is a rapid deployment model. You cannot have that with bare metal. You certainly have limitations when you go to VMs, but Docker enables you in a way that you can, be able to boot them at a very, very fast rate with a small footprint and make them completely stateless. So with that, we come to the main part where we say Docker inside OpenStack. So Docker has been part of OpenStack for some time now. It exists in different shape and forms and also in different projects. One of the implementation which has been there for the longest time over here in OpenStack was through Nova compute program. So the way Docker would work with Nova was and is through a compute driver, just like the way libnetwork works. You could have other hypervisors as well. In this case, you have Docker containers running as Nova instances because of the way Docker Nova Docker driver plugs into Nova, abstracts all the maps all the interfaces of Nova onto the Docker technology which runs at the backend. This has been in the Stack Forge. We'll see where this goes. I'll talk about some of the things which are coming in the future. So just to give you another overview of what Nova Docker is and what Nova API is and what Nova Docker is and what Docker is. So the thing, Nova has some sort of APIs and then Docker has some sort of functionality. So all the APIs that Nova has, they are not implemented by Docker. Docker does not have all of those functionalities like supporting metadata and things like that. If you have Docker technology and it has a lot of feature set which are not exposed by Nova APIs. So what we're looking at over here in this particular section is an overlap of Nova APIs and Docker technology. Then there is Heat, in which you can, using templates, you can deploy Docker containers, but it's not really a proper orchestration model. But then our, which is the popular one, Magnum, which is there on, is the container as a service for OpenStack, which is trying to bring in all type of container technologies inside OpenStack right now. It's a lot of development is going on in this area. I'm also being involved in the discussion around networking. I'll talk about some of the things which are going on in Magnum. So in the scope of this presentation, we'll go over what is already there and what works, and we'll also suggest on the next steps. So with that, let's talk about the networking aspects of Docker. We say Docker technology is awesome, so we also have to realize that networking for Docker has to be awesome as well to make sure that this entire thing works awesomely. And as part of the background of Docker technology, when Docker came out, we all know that Docker, the famous Docker Zero Bridge, is like a Linux bridge, which like an L2 switch, which runs in the Linux kernel, and then which allows communication from one container to the other, or even host to the container over this bridge. And then you have this Docker proxy using IP tables, which has some magic when you have communication outside the bridge. That's one of the technologies which was there in the early days. Then you could also use Unix domain sockets to communicate from one Docker to the other, from container to communication. And then you could also have another option where you could say my container is directly hooked onto my host machine through the host network, where your host could talk to the container over some privileged ports. So that's these are some of the things which were there. However, when we look at them, this is very primitive networking. If you take this to any IT admin, they would not be comfortable using these, and that's why things have changed in last, let's say, 6 months, when some of the new networking aspects have been introduced in the Docker technology or Docker program. And those new concepts, when we talk about those, is called libnetwork. What is libnetwork? Libnetwork is like a networking framework or a networking API, which is there to provide networking for Docker container. Just like libcontainer was introduced or libswarm was there, now libnetwork has been introduced. So what you're looking at over here in this diagram is called container network model. So the way a container network model works is that it has three main components: a network sandbox, and an endpoint, and a backend network or a network. So a sandbox is something where the networking for a certain container resides. An endpoint is something which attaches to a network sandbox and allows communication from a container over to its network. And network is something, is like a group of endpoints which allows you to have communication across these multiple endpoints over this particular IT domain. So these are the concepts which came out of libnetwork as part of container network model. Work has been going on in this area, and I'll comment on that in the end on what exactly is the progress so far and what exactly is coming next and what do we expect when. To give you an analogy of a libnetwork, which is new, and the container network model, I'll talk a little bit about a Neutron because there are some things which match, which kind of look very similar when we talk about libnetwork. So let's take an example of Neutron here. Neutron is has an API which has this notion of plugins, and through plugins you can have some backend technology hooked onto it. In this diagram, what you're looking at over here is a Neutron API has Plumgrid Neutron plugin running, and Plumgrid Neutron plugin has the Plumgrid ONS backend hooked onto it. So if you create networks or routers or ports, they would go to Neutron API and they would go to Neutron plugin and then to the backend. Libnetwork works in a very similar way, and that's where I'm going to talk about the comparison of the two. So let's say you have the container network model and you have Neutron. So libnetwork is also pluggable, just like Neutron is. And in libnetwork, you can have drivers which you can load as part of the framework and have them talk to different backends and provide networking. So when we say containers and VMs and bare metal, if we start coming up with different solutions for each of them, life will become a little bit difficult. So ideally, what we should be going towards would be common networking layer for VMs, containers, bare metals, or whatever we have, so that network admins can really adopt it in a way that they don't have to implement different things for different solutions. So with that, let's talk about one of the use cases exactly around this area where we say there should be common networking layer for different, let's say, hypervisor technologies, or let's say even different virtualization technologies. In this case, you have one compute node which you're looking at over here on the right side is Nova Compute running with libvirt, and you have another compute node which is running Docker engine with a couple of containers, and then you have Neutron which will provide networking for both. So the way it will work is Nova, as we know, is pluggable in a way that you can run multiple drivers at the same time. You can have a group of compute nodes which have libvirt running or provisioning VMs, and then you have a group of compute nodes which are provisioning containers using Docker. But then you have Neutron, which is one layer, and that one layer can provide you networking for VMs and networking for containers both at the same time, just the way we look at over here in this diagram. And then all the permutation and combinations of network connectivity can be done. You could have container to container networking, you could have container to VM networking, you could have VM to VM networking, whatever you can think of. This use case is very specific to what is there today, and this was chosen out of several other, but this is the one we'll talk about in this presentation. The question is, you guys must be wondering, when we say VMs are provisioned on Neutron networks, it makes sense. We have played with it, we have seen it, and we kind of know how it works. But when you say you have your set of compute nodes which are running Docker at the back end, and then Neutron is connecting to those containers, how does that work? Let's give you an example over here on the entire workflow of how exactly that works. So you have Nova API and Nova Compute. Nova API, what it does is that user talks to Nova API to make a request like, okay, create a VM, boot a VM for me, and that VM, or sorry, boot a container for me, and that container is going to use the Docker driver. The call goes to Nova Compute, and what Nova Compute would do is that figure out what network ID is associated to that particular request. It will query Neutron or request Neutron to create a port, if it's available, for that particular VM to be associated with the interface. And that at that point, Neutron will talk to the backend, Plumgate Neutron plugin, and then talk to Plumgate ONS backend to provision that particular port. Now the call would go to Nova Docker, which is the backend Nova driver for provisioning Docker containers. At that point, the port object would be there. Container Nova Docker will have a WIF driver inside it, which is a Plumgate iOS or WIF driver. What it would do is that it would take the port information and plug that Docker container into Plumgate ONS backend. At that point, it will go ahead and launch the Docker container. And when the container is launched, it's going to have the interface of that particular Docker container attached to the network, which was requested as part of it using the Neutron port. And as soon as the Docker is up and running, it will have instance connectivity onto whatever network is it connected to. So with that, question you guys must be thinking over here is that, well, is this even real? You could have one networking layer for containers and then one networking, same networking layer for containers and VMs at the same time using Neutron. Well, yes, it is, and that's something I'm going to give a demo about. So let's go over to that. This is going to be the demonstration of what exactly I was talking about. So in the demo setup, what I'm going to be running over here is the last stable OpenStack release, Kilo, using DevStack. It's going to have Neutron enabled with Plumgate ONS plugin. We have two compute nodes. One node is controller and a compute. That node is running Nova Docker driver with a couple of Plumgate components. Then another compute node is running Nova libnetwork driver with a couple of Plumgate components. And at this point, this entire setup is capable of providing all the networking needs that you need, from all the simple L2 domains to routers and external networks and porting IPs and everything. So this is the demo setup. What I'm going to do in the setup, in the presentation, in the demo, will be that I'll provision a network using Neutron. I'll spawn a VM and a Docker container on that same network. Then we'll validate connectivity across hosts. Using one side is going to be having a VM using libnetwork connected to Neutron network, and then on the other one, another compute host running Docker connected to Neutron network, same network, and they'll have connectivity across hosts. So think of it in a way that same network with two different compute hosts, different backend VM technologies or container technology, and then they're talking to each other over the same networking layer. Then we'll create a router, attach the router to the private network, attach to the external network. We'll ping OpenStack.org or Google, and then associate floating IPs and check connectivity from outside to inside. We'll also update security policies to see how the network topology disallows the traffic. What we will end up with in the end would be something like what we're looking at over here. What you have is two servers, server 1 running Docker compute, server 2 running libnetwork compute. They are both connected from the physical topology point of view through a physical network. So they have both one interface attached to this physical network, which you see at the bottom. Then you also, the VM in the server 2 and the Docker container in the server 1, they are both connected to the same virtual network provision by Neutron through PlumGrid ONS plugin, and they'll be able to communicate. So through the overlay network which we have over on this physical layer, and then you could attach the router to this virtual network, and the router could attach to a NAT to the internet, and you could have all sorts of use cases which you're looking at. So with that, I think I'm going to minimize this and go to my demo. Dheeraj, can you see my screen?
Yes, I can see your screen.
Okay, perfect. I'm going to go over the demonstration, what I just talked about. We'll be using Horizon in this demonstration, which is the OpenStack dashboard, and we'll also be using PlumGrid console or PlumGrid UI. So using both of the user interfaces, we'll be going over this demonstration. All the work will be done from OpenStack UI or OpenStack dashboard, and in the PlumGrid console, it's just going to be read only, and we'll see how we can visually see them in the PlumGrid console, because there's going to be some differentiation when we spin up containers. So let's go over that. Let's look at the PlumGrid console page. So that's PlumGrid console. Let's log in as the admin using admin credentials and look at the setup. In the hypervisors, what we have is one hypervisor is running Docker, and the other one is running libvirt, Cameo over here. So you see two hypervisors over here. Both of them are shown in the Nova inventory for the hypervisors. What I've done over here is I have provisioned host aggregators, which is a beautiful Nova feature where you can define availability zones and put different group of hosts in a particular availability zone, so that when you provision VMs, you can schedule them on the right technology in a sense that they're not incompatible with each other. And we'll see how that works. So we have two availability zones, Docker zone and libvirt zone. Similarly, I also have two sets of images, two types of images. One is for libvirt, which will work for VMs, and another is for Docker containers. So both are zeros. We'll have to spawn them in a sense that the libvirt zeros get spawned onto the libvirt compute nodes, and the other one on the Docker compute node. If we go to the PlumGrid console and see the inventory, so this is what you're looking at over here is the PlumGrid zone. We have two compute nodes which show up over here as part of the zone, and we'll be provisioning these containers and VMs. We'll see how that looks like in PlumGrid as well. So I have there's some echo going on. Maybe I'm not sure. Someone needs to be muted.
I didn't hear any. Let me.
Okay. Maybe it's from your side. Not sure. Thanks. Okay, so let's log into the project that I have. It's called Docker Networking Demo Project, and we'll be using this OpenStack project to go over the demonstration of connecting container VM on the same network and seeing how networking works. So what we're looking at over here is the network topology, which is empty right now. It just has the external network, which is pre-provisioned as part of the setup installation. Let's see how that looks like, this tenant looks like in the PlumGrid console. We go to this tab called Virtual Domain View, which is equivalent to a project in OpenStack, and we see nothing in the network topology except for the default security group, which got created as part of the tenant creation. So let's go and create a network for Docker Networking Demo Project and associate a subnet to it. And so let's call it a Docker. Let's call it Docker Demo Network. And let's create a subnet, Docker Demo Subnet. The IP is 192 168.0.0/24. Let's make sure DHCP is enabled, and yes, it is. Let's create it. At this point, we have the Docker demo network created. If you go to PlumGit console, the Docker demo network shows up as an L2 switch with a DHCP since been enabled, a DHCP over there. So if we go back and look at the compute nodes, we see that in the instances, there's nothing over here because we have not created any instances so far. There are no VMs, there are no containers. And we'll see the similar picture on the compute nodes. I have two compute nodes here, Docker compute and libvirt compute. So let's make sure that we don't have anything existing running right now. So on the Docker compute, and this is a libnetwork compute, let's run some commands to see if there's anything running. So let's do Docker PS. We see that there's nothing in the list of containers here. Similarly, let's do a verse list on the libvirt compute. We see that nothing is in the list, just like we see in Nova inventory, since we did not have anything created. Now this is where the availability zones I was talking about come into the picture, where the host aggregates like Docker zone availability, libvirt zone will be used when we schedule these Nova instances on these particular compute nodes so that they get scheduled on the compatible backend technology. So I have the Docker. Let's create a container first, since this is a Docker session. Let's pick up the image, which is the Cirrus, which is for the Docker. Let's select the security policies, default security group. In the networking tab, we select the Docker demo network we just created, and let's provision the container now. It should be up very soon, and it is. Yes, it's active. It has the IP address 192.168.0.2, and it is in the Docker zone availability zone. We should be able to see it on the compute node where Docker is running. So let's go and see. If we do Docker PS again, yes, we see a container which was created 14 seconds ago, and if the UUID what we're looking at over here should match the one which is in the Nova inventory. So that should be 3B2EE, and yes, we're looking at the same UUID. So we have container already provisioned. Let's log into the container or run a command inside the container to see if this container got in the IP address, the one which we see in Nova. So let's see. We have, if we do interface config, 192.168.0.2, and similarly, if you go to Nova, we have exactly the same IP address, which is great. Okay, so now let's go and spawn the VM in the other libvirt zone availability zone. Let's call it VM1. Let's make sure we pick the right image so that it's compatible, and let's provision it on the network, same network. These two Nova instances will get scheduled on different compute nodes, as we talked about in the diagram in the presentation. So we have the VM up and running as well, and the VM looks like has an IP address 192.168.0.3. If you go to the libvirt compute, we should see a VM in the verse list. Yes, we do. Let's quickly compare the UUID as well to make sure we're looking at the right VM. So verse.xml ID of the VM, except for UUID. So the UUID looks something like 62DFF, and in the Nova inventory we see, it's look like 303855, and in the Nova inventory we see the same UUID. So that makes sense. So now let's look at how this looks like in the network topology in OpenStack. So when Nova shows two Nova instances connected to the same Neutron network, let's see how this looks like in the PlumGit console. So what we see over here is we have a container and a VM connected to the same L2 domain, and they should be able to talk to each other, and that's where the traffic will go through. So now let's go and log into the VM and see if it got the correct IP address, just like we checked in the container. So this VM should have the IP address 192.168.0.3. So zeros, and let's do interface config to see. And yes, we have the correct IP address 0.3, 192.168.0.3. And from here, let's ping the Docker container and see if the connectivity works. So we're going to ping the container from the VM. We see the ping is going on. And from the container, let's ping the VM, and the vice versa we're doing over there, ping 192.168.0.3. And we see the traffic is flowing as expected. So what you're looking at over here is traffic going through one L2 domain across two different physical servers with two different compute technologies, Nova compute technologies. You have Docker and VMs connected to each other through one networking layer or common networking layer. Now let's look at some of the L3 concepts and connect them to the same topology to see if all the other types of networking works as well. So I've just created a router, and in the network topology, what we see is that network and a router which are not connected to each other. If we go to PlumGrid console, in the PlumGrid console we see a router which is not connected to anything, which we will shortly connect to the network to see the L3 traffic in effect. So let's go to the interfaces and add the interface onto the Docker demo network. As soon as this is connected, we should be able to see the same interface in the network topology and also in PlumGrid console. So let's check how does this look like in the PlumGrid console. So it looks like this got connected to the network. It should have the IP address which we saw that got assigned to the interface over there, which is 192.168.0.254. So now let's go and set the gateway on the router to talk about some of the external connectivity concepts. So with that, we should be able to see that our container and the VM, which are connected to the same network, should be able to talk to the external world or physical world. So what you're looking at over here is physical or private network connected to the router, which is connected to the public network, which is called external here. And in the PlumGrid console, what you see over here is a router connected to a NAT, which is going to the outside world. NAT is for floating IPs. So now let's go to the VM, and let's also go to the container, and let's do some pinging again. All right, so let's ping 8888 from the VM, and we see the traffic is flowing, which is great. Let's do the same from the container as well. And the traffic is flowing as well. So both of the container and VM are able to talk to the outside world. Let's ping openstack.org. Okay, and we're able to ping OpenStack as well. That's great. Now let's associate floating IPs to these instances to see how the connectivity from outside to inside would work. And we'll choose the same external network for floating IP association. So one floating IP will go to the VM and the other one will go to the container. And with that, we'll go to one of the nodes which is on the infrastructure, which is on the physical side of things in this particular setup, which lies on this particular subnet. and we should be able to connect to these containers and VMs from outside. So I have a base host machine from where I should be able to ping the floating IPs. So let's ping 192.168.122.36, and yes, I remember to ping it from outside. Let's also ping 39, and yes, that works as well. Let's try SSH into the VM, which is 192.168.122.36. And let's see if it is the same one which we were looking at, which had the IP address 192.168.0.3. And yes, it is. So we checked ICMP and TCP traffic from outside to inside over floating IPs. Now we have the ping going on, and we're going to disturb the security policies or change the security policy rules to see if the traffic stops. So let's quickly do that. So in the security policies, in the security groups, I will go and remove all the rules so that traffic should just stop. So as soon as these go away, I should see the packets from VM and container to the outside world should stop, and they have stopped. No more traffic going on. You see the pings are not going through anymore. Let's see what, as soon as all of these rules are removed one by one. So they are gone, no more traffic. We should also be able to double check that traffic from outside to the inside should not also work, and which is not working in this case. We can't ping, we can't SSH, either of those, and that's what we're looking at from a security policy, floating IP, routers, L2, DHCP, everything. So all the functionality that Neutron is providing over here, all the feature set, Docker is seamlessly able to consume those, or containers are seamlessly able to consume those as if they were consumed by VMs or as if they were consumed by bare metal at some point. And this is the beauty of common networking, where you don't have to worry about reinventing something new. And I'll talk about in a few minutes about where the new direction is going and what's expected in the next few months on networking for Docker containers. So this is a topology diagram which I was just looking at, and just to end my demo over here, this is how the topology looks like in the PlumGrid open networking suite. You have a router and a NAT connected to the outside world. So with that, I would like to jump back to my presentation. Okay, so just to give you guys a quick recap of what I just did. I provisioned a network, and I spawned a VM, and I spawned a Docker container. I connected both of them onto the same network. These two Nova instances, a Docker and a VM, were provisioned on two different servers, which are connected to the physical switch. Then we validated connectivity over the virtual network for these two instances. We also connected a router to this private network and router to the external network to check connectivity from the virtual network infrastructure to the physical network infrastructure from inside to outside. Then we associated floating IPs to check connectivity from outside to inside for ICMP and TCP, and then we also removed all the security groups to see if the traffic gets disallowed. So this is where some of you must have been wondering what's coming next. We've talked about Nova Docker. Nova Docker has been there, is there, but Magnum is coming. So Magnum is probably going to be the containers as service solution for OpenStack, and we would want to have networking as part of this as well. So I've been part of discussions for Magnum. There are a lot of threads going on. They are in active discussion today, like as of today, and a lot of there are a couple of directions which people are considering, and let's see when and if they converge. So one of the directions which would make sense would be to have Neutron do all the networking for Magnum, which is the proper way of doing it, and then the other would be to have some other technologies do networking for Magnum, but then you also have some way to plug Neutron in. So it would make sense to have one solution for Magnum networking instead of two. and there are a couple of specification documents going on around which are in current review is in progress, and let's see how that goes. The idea with Magnum networking in any case would be to provide Neutron API for containers networking in Magnum. So Neutron does its job, which is networking, and then Magnum does its job, which is containers. And with that, you would have an end-to-end solution in this beautiful cloud management system called OpenStack.
Yes,
yes.
I got a quick question.
Yes.
So the question which came to me was in regards to Google's Kubernetes program, like how does that fit into this Magnum networking, and what are Plumgate's thought about it?
Okay, great question. So Kubernetes is going to be part of Magnum. There is Kubernetes or let's say Mesos or let's say Docker. These are going to be fit into Magnum anyway, and that's from a compute perspective. When we say networking, that's exactly what I'm referring to, that being Google coming into the picture and they're introducing their support for this particular project in OpenStack through Kubernetes, it makes sense. But when you talk about networking, we are still discussing, and people from all the companies and all the different areas and all the stakeholders are discussing what to implement. There are options like Flannel and Weave, which work out of the box with those container technologies. But when they have to be brought into OpenStack, we have to see how will they work. And when they will work, there could be options like, let's say, libnetwork could have a plugin for Neutron, which would work with Magnum. Or we could have another project which is just recently kicked off. It's called Career. That project is designed to provide Neutron implementation for containers. So that's also something we could actually consider for Magnum, and that would work seamlessly out for Kubernetes or whatever container technology is there. This is an interesting point over here because there are 7 different options which we could go with. If we could just sleep for 7 months and wake up, we'll only have one option. So we'll see in next few months. It's a very interesting time. We'll see in next few months, let's say by Tokyo or even let's say by Austin, we'll have the proper convergence on what exactly it's going to work in the end. So in terms of the option I have described, it's going to be Neutron directly, or it could be Neutron through libnetwork, or it could be Neutron through a project called Career, or it could be dual implementation, Neutron as well, or something else as well. So a lot of options on the table.
Okay. Another question which came was is in regards to, so you showed us this demo. What people are wondering is if they have anything they are doing with Plumgate already, or they want to evaluate the work you have done and whatnot, how easy it is for them to go to the OpenStack library and try this. It's just for their own knowledge purposes.
Yes, it's actually very simple. I think for that, I would recommend reach out to our support team, our customer team, and they should be able to give you instructions on how to go with the demo of this. It's pretty simple. The instructions are quite simple. I have also these instructions somewhere on the GitHub, but I think a proper channel will be to reach out to them, and they'll be able to respond to you very quickly. Okay.
Thank you. That's pretty much the
Perfect. Perfect. Okay. So key takeaways from this presentation: we know that Docker has arrived in OpenStack. It arrived a long time ago as part of Nova Docker. Now it's part of Magnum. Networking has evolved in general for Docker containers, but it has to be improved, and it has to be converged onto something which everybody can use. So that's something we should keep an eye on. And then Plumgate ONS is capable of enabling all sorts of networking options for containers, VMs, or anything you can bring. So common, just like I showed a demo of how you could connect your containers and VMs seamlessly and have all the use cases of networking, regardless of agnostic of what compute technology are you using, it would work. So with that, Q&A. Any other questions if you have?